Good afternoon, everybody. Good afternoon. Hope all is well and everyone's doing all right. As always, I'm going to wait for everybody to get in and then we'll get started. All right. So, hope everybody's doing great. Everybody's doing all right. Let me clean this up a little bit. All right. So, if I'm not mistaken, we're getting into 4.4 today. Functions.
And you should stay in the corner.
Say again. Was that for me? All right, guess not. All right, so we're looking at 4.4 today, functions. And we're going to start off with the definition of a relation. All right. Wonder why this is so off. All right, so a relation is going to be any set of ordered pairs. All right, so example here, we have 1, 2, 3, 4, and 5, 6. So like I said, relation is just any set of ordered pairs. All right. So a domain is the set of all first components of the ordered pairs. That's 1, 3, 5 in this case. So you got 1, 3, 5. I'm going to scroll up some. Then we have our range, which is the set of all of the second components of the ordered pairs. So everybody done with that first part? All right, so that'll be 2, 4, and 6.
Was there anything over top of the first one? How you doing? Saying domain the set of all first components of the order. Was it something over top of that?
Well, that was the first definition. Tell me that.
Okay, I just wait and go back to when it finished. I'm sorry. Go
Okay.
ahead.
Okay.
Thank you.
All right.
Thank you.
Just don't let me forget.
Okay, you too young. Okay. Okay.
Is everybody good with range?
Yes. Okay.
Everybody is good. Let me see how much was before that. Well, that's all it was. So if everybody got range, that's the beginning right there. If you want to get that real quick.
Yeah, okay, wait a minute. Order. Oh, okay.
All right.
So that's where we started on 4.4.
Yes.
Okay.
This way.
Thank you.
No problem. All right. So comparing domain to range. So your domain is the first component, range is the second component, what we just mentioned. So that means your domain will be your X variables and your Y will be your range will be your Y variables. Domain will be your input, range will be output. Domain is considered independent variable. Range is considered your dependent variable. And then it also means your domain is your horizontal axis or will be on your horizontal axis, and your range will be on your vertical axis.
So we weren't supposed to write that?
Oh, no, I'm just gonna rewrite it a little neater.
Oh, okay.
I don't know why. I think I wrote on this when I was first getting used to this computer and I just never changed it. So it took a little while for my handwriting to get somewhat decent.
Well, thank you.
No problem.
A function, okay.
Yep, definition. Yep. So we have a function as a relation in which the elements from the domain corresponds to exactly one element in the range. All right, how are we looking on the definition? Can I scroll up? So a function is a relation in which the elements from the domain corresponds to exactly one element in the range. So we want to determine whether each relation is a function. And we'll write it over. All right, so we have the relation of 1, 6, 2, 6, 3, 8, and 4, 9. And you want to know, does this represent a function or not? So one way we can do this is by setting up a mapping. And I'm going to erase this. Obviously the answer over there in the purple circle, but just want to show you how you would do it. So our domain consists of 1, 2, 3, and 4. Our range is 6, 8, and 9. You don't have to write 6 twice. 6 is going to be 6 no matter how many times you write it. All right. So now you have to ask the question for each individual domain value. What we're saying is, does the domain correspond to exactly one element in the range? So if you can answer yes for each one of these values over here, then you have a function. So notice 1 only goes to 6. So the answer is yes. 2, even though it goes to the same number that 1 goes to, but you ask yourself individually, does 2 only go to one value? The answer is yes. All right. You say, does 1 go to one value? The answer is yes. That number is 6. Does 2 go to one value? The answer is yes. The number is also 6. Does 3 go to one value? The answer is yes. Does 4 go to one value? The answer is yes. Because you can answer yes for all of these, and that means you have a function. So you look at each individual domain value. Does it go to one number? If the answer is yes for each one of your domain values, then you do have a function. All right. Questions before we look at another relationship that pretty much is not a function?
Yeah.
Yes,
All right.
go ahead.
So, what makes that yes?
So you're asking this question. You remember what makes it a function? That domain corresponds to exactly one element in the range. So does it go to one value?
So when you
Now,
say one
it
value,
may be more clear when I show you the next example.
okay, because I'm not understanding what value.
So
what value is.
let me show you the next example.
What's right here beside the 3 and the 8?
Beside the 3 and the 8, right
4,
here.
9.
4, 9. Okay.
Oh, you're just talking about the ordered pair. Oh, okay. I didn't notice what you're talking about. Okay.
I can't see it. Yeah.
Okay. Yeah, it'd be 4, 9. So Ms. Glover, like I said, let me show you this next example, and it probably make things a little clearer. All right. Can I scroll up?
Yes.
Okay. Don't worry about
The
that.
D stands for domain, the R stands for range. Okay.
Uh-huh.
Okay.
All right. So this time we have 6, 1, 6, 2, 8, 3, 9, 4. So the values that are in our domain is 6, 8, 9. Those are the first components.
I'm supposed to write that down.
If you want to.
I can't write and you get what you're saying at the same time. Give me 1 second, write it down.
Mhm.
We deal with old people here.
We
Nah.
are old.
Yes, ma'am. I'm glad to get there, but sometimes it's okay. So that's 6, 8, 9. 1, 2, 3, 4. Okay.
Okay, I gotta ask a question. This might gonna sound dumb, but I gotta ask.
Mhm.
Okay, now in the domain, you switch, did you switch them?
Well, these are two separate examples.
Oh, okay,
These are two
okay.
separate examples. So it just so happened that they switched them, but that has no correlation between with anything. They're just two separate examples.
Okay,
All right. So now this one is not a function. You see the answer right here telling us it's not a function. The reason being is because notice that the number 6 goes to two different values. 6 goes to 1 and it goes to 2.
6 goes
I'm
to
not
1.
understanding the value though. I mean, when you say the value, I'm
What
not
you mean?
understanding the value. When you say the value,
Mhm.
I'm not understanding what you're saying.
Okay, you see what we have going, you see up here, right? The order
Mhm.
pairs. So what relationship, you see that relationship, right? That's 6 to 1,
Uh-huh.
6, 1, and this 6, 2,
Yes.
8, 3, and 9, 4. So you create that same relationship here.
Oh, okay.
Okay. Okay. Okay. Okay. Okay. And the 6
Thank you,
going to
Professor.
1 and the 2. That means
No problem.
no.
Right. And so now when you go back up here, all of these went to one value. See,
Right,
1 only
okay.
goes to 6. 1 doesn't go to anything else.
Gotcha.
And 2
Right,
only
okay.
goes to 6, 3 only goes to 8, and 4 only goes to 9. Now, just because it's repeated right here, that doesn't change anything. 1 only goes to 6. 2 only
Okay.
goes to 6. They only go to one value. And so now when you go here, 6 goes to two different values. It goes to the number 1 and it goes to the number 2. And 8 goes to 3, 9 goes to 4. But
Okay.
because 6 goes to 1 and 6 goes to 2, that stops it from being a function.
Go back up to the top for me 1 second, please. To the first example.
Mhm.
Because you know me, I gotta be difficult because I'm noticing we only got 3. Okay, so 1. So at the top, 1 go to 6 and 2 go to 6. So
Mhm.
why ain't that the same thing as the bottom?
So you got to ask yourself the question. You're looking at your domain. Does each value in your domain go to one value in the range? And you ask the question individually. How many values does the number 1 go to?
6.
Well,
One,
6
one,
represents one
one.
number, right? So how many values does the number 2 go to?
Just 1, which is
Uh-huh.
6 also.
Now, we didn't ask you if anything was repeated. We just asked you how many values in the domain, when you look at the domain, how many values does that number go to as far as the range is concerned? And if you can say it's just 1 for each one of them individually, then the answer is yes, that it is a function. But see, going back down here, 6 goes to two different values. It goes to 1 and it goes to 2.
Gotcha.
So, and we're going to look at a general way of looking at it in a second. But in other
So-
words, we could have a repeated value here, but you cannot have a repeated value in your domain.
Is it because you switched the ways? Because now you put the larger numbers over here and the smallest over there?
Well, it's not necessarily, because I don't want you to take that and say that that's a relationship, because that's not going to necessarily be the case. It just so happened to be the case in this scenario.
Okay.
It's not going to always be the case. So I don't want you to say, well, the larger numbers over here, smaller, say, I don't want you to make that correlation.
Right.
But it's just all about asking yourself the individual question for each number in your domain. When you look at the domain, does it go to one value in the range? If you can say yes, then you go on to the next one. Does 2 go to just one number? The answer is yes. Go to the next one. Does 3 go to one number? Does 4 go to one number? So if all of them are yes, then the answer is yes, it's a function. Now, if one value in your domain it goes to more than one number, then it's not a function. And that's how you would determine it. So anybody, before we look at these general statements, any other questions on what we did there? All right. So here are some general ways of looking at it. There can be a repeated value in the range, but no value can repeat in the domain. So that's what we saw here. Notice we had the 6 repeated here in the domain. That stopped it from being a function. But when it was repeated in the range, it was still a function. So that's what I'm talking about there.
Let me write that. Look, what they say, there can be no repeated value.
There can be a repeated value in the range, but no value can repeat in the domain.
Can be a.
And then it says the range can go to more than one value. The domain can only go to one value.
Range. But. All right, sir. Thank you.
No problem.
Thank you.
Anybody else holding on to these statements before we go to the next
Me.
example?
You gotta write both of them down. Wait a minute. I thought that was next part.
That's up to you.
Yeah. Because
Okay, now I'm gonna ask you, what's this word right here? The range can go to more than, okay, more. Why don't I look at take my glasses?
Will you ask the question and answer it right quick?
I ain't want to blame it on nobody else. Thank you. Okay.
No problem.
Whew. This class make your brain work. So it can be repeated value in the range, but no one can repeat in the range. The range can go to more than one value. The value can go to one value.
All right, are we good with these statements?
Yes, sir.
Okay, I'm sorry again. The range can go to
More than one value.
value.
The domain can only go to one value.
Oh, I don't see the word but. Okay. It ain't you.
I
It's
guess I
me.
could. No, I didn't put the but. I can put but.
I know you scratch your head when you leave us, don't you?
Oh no, it's fine. I'm good.
You and Miss Glover.
Thank you, okay.
Everybody good. All right, it looks like I left off part of this. Let me go to my other set of notes. Can we go to the next page? Everybody good?
That's
Yes,
good.
sir.
Thank you.
Thank you.
All right. Yep, no problem. For some reason, I didn't have my other stuff up there, my vertical line test and stuff. Where'd it go? Let's go here. Nah, I don't want that. All right, on my stuff at. All right. Trying to be lazy and not have to write down a whole bunch of stuff. Guess I'm gonna have to do it. It's all good. I don't know what happened to my notes. All right, so let's look at the vertical line test.
Oh, shoot.
All right, vertical line test. If a vertical line touches or crosses a graph more than once, then the graph does not represent a function.
Heck yeah.
All right, so once again, if a vertical line touches across the graph more than once, then the graph does not represent a function. So we're just going to take a vertical line and draw it through your graph. Once again, if it touches it more than once, then it's not a function. So we see this right here. Notice no matter where you draw your vertical line, it's only going to touch it once. So yes, this is a function.
It's only touching it once.
Yep, when you draw a vertical line, no matter where you draw it, it only touches it once.
It only touches what?
The graph, the line's in green.
Okay. Mm-hmm.
Here we have a circle. Touches it twice, so a circle would not be considered a function. Parabola, no matter where you draw a vertical line, it will only touch it once. So yes, it is a function. And then this graph over here, even though over here it only touches it once, but here touches it 3 times. So this is not a function. All right, questions on what we did there before we go to the next thing?
Yes. On
Mhm.
this one down here and making a U, you made a U. Okay, where did you start?
What you mean?
Okay, if we was to have to draw that graph with a U, how did we? Okay, we started here.
You just talking about like that, or not understanding what you? Well, if you're just talking about drawing, I didn't. Now I didn't draw these with any type of accuracy or any type of detail. I'm just giving you an example of how the vertical line test work. If you just talk about,
okay, that's why I'm lost. Okay,
yeah. The green lines, the circle, and all that stuff like that. That's just a sketch of a graph, just very loosely. But I'm emphasizing this process right here.
Right. Okay. Thank you.
Mm-hmm. All right. Any questions before we go to the next one?
Oof.
Still see writing. Scroll up. Everybody okay? Everybody done with the graphs?
Yes, sir.
So function notation. This is a function notation, just basically states that y is equal to f of x. When you have f parentheses x, the way you say that is f of x, just like if I had g parentheses x, it's the same thing. What you would say is g of x, or if you have h of x or r of x and so on. So if I have y equal to 2x plus 1, if I replace y with f of x, this is considered function notation.
If you replace y, well,
F of x, that f parentheses x, that's considered being in function notation. And so they would expect that you know that y and f of x are interchangeable. They mean the same thing. You can go back and forth between the two, and it doesn't change the value of the problem at all. F of x and y are the same thing. They represent the same thing. It's just that one is in function notation, the other one isn't.
Oh, okay. So that there is just a rule right here. F of x equals 2x plus 1. That's a known rule or something.
That's writing it in function notation. If you want to write your equation in function notation, then that's how you would write it.
Okay.
So what it does is that gives you someone the opportunity or the ability to give you extra information. With mathematics, a lot of times writing with the least amount of words possible or giving you instructions with the least amount of words possible seem like that's their goal. They could write find f of 3, or even if they just wrote f of 3, and you could find f of 3 by taking what is already established as f of x, which is this. Now that has to be established. They have to tell you what f of x is. And then that just means that you're going to plug in 3 wherever x is.
Oops, my bad.
No problem. So you see f of 3, and that's what this is right here. That's f of 3, because you replaced the 3 with the x. Instead of saying f of x, now you're saying f of 3.
Wait a minute. Let me write that down. Good. Okay, example. Find f of 3. F of 3 equals 2 times 3. Okay, got that. Wait a minute. Oh, you finished the problem off. I see. I was right. So F.
So, yeah, so you plug in 3 into your function, then you go ahead and calculate 2 times 3 is 6, 6 plus 1 is 7. So you see the f of 3 is equal to 7, and then also, you know, that means they give you the information as far as the order pair is concerned. Remember, you plugged in 3 for x, and you get out 7. So that's going to be your y. So that means your order pair will be 3, 7.
Wait a minute, let me write that down. Okay, that equals plus 1. Okay, so F. Let me make my arrow down there so I know where I got that from.
How did we come up with the 3 though?
Directions, it said find f of 3. They gave you that.
Gave us 3.
So they would tell you what to plug in.
Oh, okay.
Mhm. Everything was given. You just need to know what this means when you see it. That means plug in
Right,
3
right.
into the function. Mhm.
I mean, I know I'm slow, but I'm just looking at it like, wow, how did
Oh,
he get
no.
Is
No, the only thing you had to find was the 7, and you wouldn't find that
right?
until you plug in the 3 and calculate.
Okay.
Mhm.
all right. Please, can you read Bible teachers?
All right, questions before we do a few more like this. Somebody say something in the chat. All right, someone is asking, can you mute so that I'll make sure everybody can hear everything. So,
Okay. Moving a chair.
all right. So is everybody okay with this before we go to the next example? Make sure we're all right. All right, so let's do this again. Just gonna do a few more. Let's see something. The functional table. Let me see. Given. All right, so just making up problems. So let me see. Someone said something. Somebody said I didn't finish your statement. So let me know if you have a question there. So it says, they give us these functions. We got 3x minus 5 for f of x is equal to 3x minus 5. G of x is equal to x squared plus 7x plus 2. Then h of r is r cubed minus 3r plus 4. And they tell us to find f of 0, g of 1, h of 2. All right, so
So we just plugging in everything for what you have next to F, G, and H.
Yep, that's it. Yep. You don't want to say anything, but I have a hard time concentrating. Oh, no problem. No problem. Okay, I see you saying y'all talking. Okay, cool. That wasn't for me. All right, so right, sir. So what we're gonna do is, and I'm glad you said that, because what I do want to make sure is that you don't plug in, because I've had this happen before. They got 9 answers. They took 0, plug it into each one, took 1, plug it into each one, then took 2, plug it into each one. So of course, that's not what we're going to do. F of 0 just applies to your F function. You know, G of 1 just applies to your G function. And then the same thing goes with H. So we're only going to get 3 answers here. So let's look at the first one, F of 0. That means I'm going to take 0, plug it into the F function for X. So that's 3 times 0 minus 5. 3 times 0 is 0 minus 5, and that is -5 for the first one. All right. Any problems with that F function? All right. So do the same thing for the G function. This time we're plugging in +1. I should have made something negative, but it's all good. 1 squared is just 1. That's 1 times 1. 7 times 1 is 7 plus 2. And that'll be 10. Any questions on either one of those before we do H? All right. So do the same thing for H. This time we're plugging in 2. That's 2 cubed minus 3 times 2 plus 4. Don't forget 2 cubed is 2 times 2 times 2, which would be 8. Three times 2 is 6, and it's still plus 4.
Okay, I got a question to ask. So right here, you said, we know there's 2, 3, so that's 1, 2, 3. So then you got a minus and you got a 3 and a 2. So you didn't do, okay, I get it. No. 1, 2, 3, then it's 8, 2, 4, 4. Okay,
So you good? Then
I think I did it because you said right here, that would be 4, and then that would be 6. Okay, I got it.
all right. All right, then finish it off. 8 minus 6 is 2. 2 plus 4 would be 6. All right, questions on that?
So the
Questions?
answer is 6, right?
Yes.
Okay.
Mhm.
Okay.
Going back to look to see if there's anything else that it talks about in this section. Nope, that's pretty much it. Okay. Questions on any of this before we leave this section? Everybody good?
So like, will it ever ask us to graph these, or we're just always finding whatever it asks us to find?
Yeah, you just find whatever it asks you to find. Yeah. So the graphing was the previous section. This is, this is all you just finding the values.
Okay.
All right, so we have one more section out of this chapters 4 or 5. Let me confirm in math lab real quick. Yeah, just 4 or 5, and then chapter 7, and then we have chapter 9, and then that'll be it. Okay, so we are coming up. We have not done a proctored test yet. Yeah, 1, 2, 3. Okay. Let me get back to the notes. Okay. So they wanted to make sure that we get some proctored tests in. They said we have to do a certain percentage of stuff that is proctored. So we do at some point have to do a proctored test. So we'll probably go ahead and get this one in and let it be a proctored test. Now, all of your tests up to this point, you've been able to do them freely on your own. And so now this test, it would be the same type of situation as you would have in class, just that I'm not making you come into the classroom. And I'm going to send you details on it and send you a list of how we will operate. So everything that I say, I'm going to send you an email with these details on it. What's going to happen is that we're going to have 2 options for our test. So option 1 is proctored. And let's see, it'll be on a certain day, one of our class days. And our class runs for an hour and a half. So what I'll go ahead and write, 90 minutes. So just like if we were taking it in class, we'll be in the classroom and we'll take it for that hour and a half time. Then what's going to happen? Let me write this too. Possible points, 100%. All right. So now let's say if you take the test and you didn't do well on it, or you knew you weren't just ready for it at all. How I want to write this? I'll just write unproctored. So I will give you option for makeup. That will be done in your own time, just like the other tests. This would not be timed. It would just be like your regular test. I'm just setting it up, the same with the same characteristics of what I just described in option 1. But here, now your possible points, it's going to be 85. So I have to put some type of, I guess say penalty for lack of a better word, to simulate the classroom option was there. The proctor option was there. Now, what this does though, is it puts you in a position to still be successful. 85 does not stop you from getting an A out of the course. If you have an 85 test average, you still will get an A if you've done all of your other homework. So what will stop you from getting an A out of the course is if you don't average an 85 test score and you don't do your homework. So that's what will stop you from getting an A out of the course. This would not stop you, but I have to put something in there to at least simulate that we did something proctored, and then there was, something a little lower for your makeup. So that was pretty much for outside eyes only, to see for they to see that okay, they had a proctor one and they had a makeup, but the makeup you couldn't get the whole 400%. So that really kind of keeps the integrity of the academic process in place. But for us, we know that this 85 is not going to stop me from getting an A out of the class. Once again, not doing your homework or not scoring at least 85 average will stop you from getting an A out of the class. So that's how we're going to do this next test. We're probably going to have to at least do 2 tests like that before we get to the final. So we'll see on the next few. but we do have to get that in there because that's being sent down from leadership that we have to make sure we do a certain amount of proctored assignments. So questions on what we do here. Oh, let me say this first as well. You will get your same 2 attempts here to get the best grade possible. So technically you could have 3 shots at getting the, whatever grade you want to get on this test. If you're just not ready on, by the time it is to take the proctor test, then you can opt out and just do option 2. But once again, this is still in place. We're in the highest score is 85. All right. So questions on anything I've said up to this point on this? Like I said, we're going to revisit the directions. I'm not going into a new section today to give you guys more time to get prepared for closing out chapter 4 because we only have one more section left. But yeah, so that's how we're going to do this next test.
So will there be a day assigned for the proctored test?
Yes, and we're going to
Okay.
talk about that next class. What I want to do is see how long it takes for us to get out of the next section to close out chapter 4, then set up a review day, then set up a test day. Yeah. It's a chance that we may not finish that next section, next class. You never know, things happen. So if we don't finish that section, then we won't, I don't want to put a date out there, then have to switch it. So yeah. All right. Questions on what I said here? Like I said, we're going to revisit the directions later. Again, we're going to put it like your classmate just mentioned, we're going to put an actual date out there for it. But I do want to close out chapter 4 so we can say, okay, we're finished with chapter 4. Here's a review day. Here's the test day. And then we'll do it like that. On that day, you will be expected to have your camera enabled. You'll bring your ID, show it to the camera. And we'll operate from there. I'll give you the password so you can get in there, all that type of stuff.
So will we still have a chapter 4 test? Or that's just will be the proctor?
Well, that's what both of these are your chapter 4 tests. That's what we're talking about.
Okay.
Yeah. That's what we're talking about, chapter 4 tests.
Okay.
And so both of them will be options for your chapter 4 test.
Okay.
Mm-hmm. Yep. And like I said, if you're just not ready, you're going to get a bad grade on it and you just want to opt out for this one, that's fine as well. You just wouldn't show up on test day. You would just wait for this to open up in that lab. All right. Questions? You could use your notes. I won't stop you. There's no way for me to stop you from using notes really, but so you can use your notes. I'm not even stressed about it. So that will be available to you. Just want to make sure that you streamline your notes so that you can, knock it out in these 90 minutes. Take a look at the test review. All right. Questions, concerns, comments, anything, anybody? Okay. So, like I said, next class, we'll get into 4 or 5. That's our last section out of chapter 4. Hopefully we can knock it out in one session. If not, we'll take 2. Not a big deal. Let's see, can we use the calculator? Yes, you can use your calculator. Not a big deal. Even if you use a calculator on your phone, that's not a big deal. You just got to make sure you show your work, whatever work is required, make sure you show as much of it as possible, which validates, you doing the work. And I'm good with it. It will not be a lockdown browser. So, do what you normally do. Like I said, just make sure you show as much work as possible to validate that you actually doing the work. Everything will be fine. Let's see. All right, cool. Anything else, anybody else before we close out today? All right. Okay. So if you guys are good, I'm good. Have a good day. Be safe. Have a great weekend. And then we'll get into 4 or 5 next class. All right, you guys take care.
All right, later.
Thank you. Take care, man.